In our previous video, we talked about the atomic radius, which talks about the size of the atom. Okay, and now we're going to talk about what's called the ionic radius, which is very, very similar to the atomic radius, but an ion, as we've learned, is something that has a charge associated with it. So either an atom has gained electrons or it has lost electrons. So when a positive ion has been formed, so a cation, we know that the atom will have lost one or more electrons. Okay, so let's think about this. Let's say we have a calcium atom that has 20 protons and 20 electrons. If you take some of those electrons away, you haven't changed the protons at all, but you now have less electrons to attract. And so what happens is that ion is now smaller than the original atom because, again, you have the same attractive force of the nucleus. That hasn't changed at all. But now there's less electrons to attract. So less electrons, but the same force means that the electrons that are left are going to get brought in a little bit closer to the nucleus. Okay, so let's look at a couple of examples here. We're going to compare Mg2+, calcium 2+, and regular calcium. And we want to go from the biggest to the smallest. So the easiest way to do this when you're talking about ions is to look at the protons and the electrons. So for example, magnesium, first of all, is farther up the periodic table, right? If you look at a periodic table, magnesium is higher up. Magnesium only has 12 protons, and in this case, so 12 protons and 10 electrons, because remember, it lost 2. Well, where calcium 2+ has 20 protons and 18 electrons, and calcium has 20 protons and 20 electrons. Okay, so in this case, we're going to go from the largest. So the largest is the one that has the most electrons in it. Okay, and so in this case, that is going to be regular calcium. Calcium is larger than calcium 2+. That's supposed to be an A. Calcium 2+, which again has lost 2 electrons. So notice that, again, calcium 2+ is smaller than regular calcium. And then magnesium, because it's higher up on the periodic table, is going to be smaller than the other two. Okay, example number 2 is calcium 2+ bigger, smaller, or the same size as argon. So you look at the periodic table and go, okay, well, calcium with a +2 has 18 electrons. Oh, and so does argon. Argon also has 18 electrons. Oh, so they're the same size. No, because remember, you look at electrons and go, oh, they're the same. Okay, but then you also have to look at protons. Calcium still has its 20 protons. Argon only has 18. So when you have the same number of electrons, which you do in this case, and one of them has more protons than the other, then the one with more protons has the stronger attraction to the nucleus, and that's going to make that one smaller. So is calcium 2+ bigger, smaller, or the same size as argon? It is smaller. Okay, and for my explanation, I'm going to basically just explain this. Since they both have the same number of electrons, and calcium 2+ has more protons, the attraction is stronger in Ca2+. Okay, so and you can see this down here below. Here on the left hand side of this table here are elements, and the gray sphere, the gray circle, is the normal element or the normal atom, and then the pink sphere, the pink circle, is once it's lost one or more electrons. So for example, let's look at aluminum here. Regular aluminum has a size of 1.48. Aluminum with the +3 charge, though, has a size of 0.51. It's almost 1/3 the size of regular aluminum simply by losing those electrons. So you can see here that the pink one is after it's lost electrons. Notice that it always gets smaller. And why? Because again, the number of protons haven't changed, but the number of electrons is less now, so it makes the attraction stronger. Okay, now negatively charged ions, as you can see down here, obviously get bigger. Okay, now why does that happen? Because again, the protons haven't changed, but now you're adding more electrons. And the electrons, remember, repel each other. So there's increased electron repulsion. That's the key there. That as you put more electrons in there, the electrons that were already there are like, whoa, 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 give me some room. And they move away from each other. Well, as they move away from each other, think about if you're sitting in a circle. And that circle doesn't have any more seats. And another person comes in and you guys are like, hey, we need to make room for this person. We need to add another chair. What does everybody do? Everybody scoots back a little bit and then they can fit that chair in there. And what happened to the size of your circle? It just got bigger. Okay, same thing here. When you add electrons, the atom or the ion gets bigger because, again, those electrons are pushing away from each other. You're increasing that electron repulsion. Okay? So, using just a periodic table, arrange these from smallest to largest, Se2 minus, Br minus, and Kr. So, in terms of electrons, Se2 minus has 36, Br minus has 36, and krypton has 36. But, so again, be very careful. Oh, they're the same size. No, they're not, because krypton has 36 protons, bromine only has 35, selenium only has 34. So therefore, in which one, since the electrons are the same, that can't be the deciding factor. It has to be the protons. The one with the most protons has the greatest attraction. The one with the fewest protons has the weakest attraction, and that one will be the largest. So the largest one is going to be Se2 minus, is bigger than Br minus, which is bigger than krypton. Krypton's going to be the smallest because it has the most protons, so it has the strongest attraction to the nucleus, since all three of them have the same number of electrons. Okay, now there's a fancy word for that, okay? Many times we talk about when things have the same number of electrons. There's a real fancy word that will make your parents think you actually learned something in chemistry. Okay, when two atoms, or three or four or five, whenever two different species, two different particles have the same number of electrons, the term we use is isoelectronic. Okay, so, and again, do you have to know that? No, you don't. It's just a fancy word that makes you sound like you know what you're talking about. So, let's look at O2 minus. O2 minus, again, I'm looking at the periodic table, with a -2 charge, oxygen has 10 electrons and 8 protons. Aluminum with a +3 charge, if you look at its number 13, that means it has 13 protons, but it's also lost 3. Hey, what do you know? O2 minus and aluminum 3 plus are isoelectronic. Okay, because they have the same number of electrons. Okay, now, which of those two would you predict to have the smaller ionic radius? Which one's going to be smaller? Again, because they're isoelectronic, aluminum has more protons, way more attraction. Aluminum is way smaller than O2 minus, okay? So which one would you predict to have the smaller ionic radius? Al3 plus, absolutely. Why? Because again, they're isoelectronic, or you can just say they have the same number of electrons, but Al3 plus has more protons, so more attraction to the nucleus. All right, and then here's just some examples of this. Okay, A, B, C, and then we will be done. So we want to go from largest to smallest, and we need to do this based on where they are on the periodic table, but also the number of protons, neutrons, and electrons. Or sorry, not neutrons, just protons and electrons. So let's go through this. Electrons and protons. So chlorine with a minus charge has 18 electrons, 17 protons. Calcium 2 plus has 18 electrons and 20 protons. Sulfur 2 minus has 18 electrons. Notice a pattern here. 16 protons. And potassium plus has 18 electrons, and 19 protons. Now, what neutral element are all four of those isoelectronic with? Argon. Okay, and hopefully you see that. Hopefully you look at the periodic table. Well, they all have 18 electrons. What neutral atom has 18 electrons? Argon. Okay, so the largest is the one with the weakest attraction to the nucleus. The weakest attraction is the one with the fewest protons, which is S2 minus. And then our next one would be Cl minus. Again, we're going from largest to smallest. And then we would have potassium with its +1 charge. And then calcium would be the smallest. Now, here's where you have to be really careful, because you think, well, wait a minute. Calcium has electrons in the 4s subshell. But sulfur and chlorine only have electrons in the third shell, the 3p subshell. How can calcium be smaller? Calcium did have electrons in the 4s subshell, and so did potassium, but guess what? They lost them. Okay, every single one of these, remember they're isoelectronic. Every single one of these has the same electron configuration now. They all have the 18. Every single one of them has the exact same electron configuration. You can't think of it as calcium. You have to think of it as calcium that's lost 2 electrons. Okay, letter B, N3 minus. Again, let's do electrons and protons. Nitrogen with a -3 charge, 10. Okay, protons, 7. Phosphorus with a 3- charge has 18. So it has a whole nother shell of electrons. So that's going to make this one bigger. Okay, and 15 protons. Normal oxygen, 8 and 8. And then beryllium with a +2 charge has 2 electrons and 4 protons. Okay, so which of those is going to be the biggest? So here's where we have to think a little bit. Now we're thinking of electron shells. The one with more electron shells is going to be the biggest. So phosphorus right away with its -3 charge is going to be the biggest. So P 3- is the biggest. Now, in terms of the smallest, beryllium only has 1 electron shell, 1s2. So beryllium is going to be the smallest. So that one's out. And now it's just between nitrogen and oxygen. So oxygen has less protons, but it has more protons, has 1 more proton, but it also has less electrons to attract. And if you're not sure, remember guys, you've got this thing up here that can help you if oxygen's in there. So oxygen's there, but nitrogen is not. Okay, so let's go back down and keep thinking about it a little bit here. Okay, oxygen has 1 more proton, but again, it only has 8 electrons, where nitrogen has to attract 10. So nitrogen has a weaker attractive force, and it has more electrons to attract. That's going to make nitrogen significantly larger than oxygen is. So that would be the correct order. Phosphorus, nitrogen, oxygen, beryllium. Okay, and I'm going to leave this last one for you to try. So you can, again, do your work there. Show me that you're doing that. And if you want to check with me, just contact me, let me know, and I will get a hold of you and make sure that you've got that correct. Okay, and that's it for Ionic Radius.